What if an AI wasn't just this giant library of old books, but an actual live agent, something that could see the world as it is right now? Well, today, that's exactly what we're going to build. We're going to give an AI a window to the outside world by plugging it straight into real-time data. So let's start with a really fundamental question. We know AIs are incredibly powerful, but how do they actually perceive what's happening in the real world? The short answer is, well, they don't. Not on their own, anyway.
And that, right there, is their biggest blind spot. See, these large language models, LLMs, they're trained on these enormous but totally static data sets. It's basically a snapshot of the world from the past. So, sure, it can tell you the average rainfall for your city in June, but it has absolutely no clue if it's raining outside your window right this second. They're kind of living in this digital box completely disconnected from the present moment.
But what if we could build a bridge to get out of that box? That is exactly what we're doing today using something called the Multi-Client Protocol, or MCP. Think of it like a universal translator that lets the AI talk to the entire outside world.
So what is MCP? It's a standardized communication protocol. It creates a secure and reliable way for an AI client, like, say, Claude for Desktop, to access external tools and live data feeds. It's really the key that unlocks a whole new world of possibilities for the AI.
So here's how it all fits together. It starts with you, the user, asking the AI a question. The AI figures out, hey, I need some outside help for this, and it picks the right MCP tool for the job. Our server then fires up that tool and calls a real-world API. In our case, a weather API. It gets that live data, sends it back to the AI, and then the AI crafts a perfect, up-to-the-minute response for you. It's simple, it's elegant, and it is incredibly powerful. All right, enough theory. It's time to get our hands dirty. We're jumping into the build phase. We're going to craft this server from the ground up, line by line. Let's do it.
First things first, we gotta set up our dev environment. We're using UV here, which is a super fast Python package installer. With just a couple of quick commands in the terminal, we can initialize a new project, create a virtual environment, add the libraries we need, that's the MCP framework and HTTPX for web requests, and boom, create our Python file. We're ready to start coding.
Now hold on, before we write a single line of our actual server logic, there's one super crucial detail we have to get right, and that's logging. See, when you're building a server that communicates over what's called standard input/output, or STDIO, you can't just print things out. That will corrupt the data stream and totally break the server. Instead, you have to write your logs to a separate stream called standard error. It's a tiny detail, but it makes all the difference.
Okay, let's get into the code. First, we're going to import the fastMCP class. This thing is the heart of our server. Then we create an instance of it, and we'll just name it weather. And finally, we'll define a constant for the National Weather Service API. This is the foundation everything else gets built on.
Next up, we need a way to actually talk to that weather API. So we'll create a little asynchronous helper function to do just that. It uses the HTTX library to make the web request, it properly handles any errors that might pop up, and then it returns the clean JSON data that we need. This just keeps our main code nice and tidy.
And now for the magic. We're defining our very first tool. Using a simple decorator, @mcp.tool, we create a function called getAlerts. Now what's so cool here is that the doc string, that little description in the triple quotes, is automatically used by the MCP framework. It tells the AI exactly what this tool does. Get weather alerts for a US state. It's that simple.
And we do the exact same thing for our second tool. We create a getForecast function, and its docstring clearly lays out its purpose: get weather forecast for a location. The AI now knows it has two brand new skills in its toolbox, all thanks to these simple Python functions and their descriptions.
And to finish our server, we just need to tell it to run. This is pretty standard Python boilerplate here. We call mcp.run, and we specify the transport method as standard. And that's it. Our server is complete. It's now ready and just listening for instructions from an AI client.
So we built the server, but right now it's just sitting there waiting. The next absolutely critical step is to plug it into an actual AI application. For this, we're going to use Claude for Desktop.
Connecting them is surprisingly simple. We just need to pop open a JSON configuration file for the Claude app. Inside, we add an entry for our weather server, and we just tell the client exactly how to run it. Use the UV command and point it right to our weather.py file. We save the file, restart the app, and the connection is live.
Okay, this is it. This is the moment we've been working towards. The server is built, the client is connected. It is time to see the payoff and ask our newly empowered AI for a live forecast.
So we just ask it a simple, natural question. Just like you would in a normal conversation. What are the active weather alerts in Texas?
In the split second after we hit enter, this complex little dance begins. Claude analyzes our question and intelligently decides that our Get Alerts tool is the perfect one for the job. It sends a command to our MCP server, our Python code runs, fetches that live data, and sends the results straight back. Finally, Claude takes that raw data and cooks up a human-friendly response.
And this is a peek at what the server actually gets back.
Yeah, it's not pretty, it's raw JSON data. It's structured, it's machine-readable, and it has all the key info, like the event, the area, and the severity. But it's not exactly something you'd want to read yourself, right?
And this is the final result. Claude takes that messy JSON and transforms it into this beautiful, clear, and genuinely helpful answer. It has successfully used our custom tool to look out its new window, see the real world, and tell us exactly what's happening right now.
This is just incredible stuff. But let's zoom out for a second. This whole thing was never really just about the weather. We need to look beyond the forecast.
What we've really done here is we've given the AI a new superpower. It's no longer just a model. It's an agent that can interact with the live internet. We've unlocked the ability for it to perceive any piece of real-time data we can connect it to. Stock prices, news headlines, tracking a package. Anything with an API is now within its grasp.
And that leaves us with a final, pretty big question. If an AI can check today's weather, if it can perceive the present in this one small way, what on earth is it going to be able to see, understand, and do tomorrow?